So hi everyone, I'm Raj. I'm a second year grad student working with RISA, and my poster is on the research a group is doing with DESI to map dwarf galaxies in the low redshift universe. So the main job of DESI is to take spectra of brighter galaxies for cosmology analysis. However, while it's doing so, the spare DESI fibers are used to observe low redshift dwarf galaxies as part of the DESI-LOSI survey. And in year one alone, we have a sample of 500,000 galaxies, of which 22,000 are confirmed to be redshift less than 0.05. So with such a large sample of dwarf galaxies, many exciting science questions like understanding quench fractions or what's the field luminosity function can be done. So if you would like to learn more about the survey, what we have seen so far, and how we select targets, which is very important, please take a look at my poster on the second floor while you go to the bathroom.
Thank you.
So hi, I'm Richie. I'm a fifth year grad student working also with RISA. My main interest is understanding how dwarf galaxies form, how they form stars over time. So what we did is we took the SAGA survey, which is satellites around 102 Milky Way mass hosts in the universe, and also field dwarfs that are below the LMC mass of 10 to the 9 that are isolated, and understand how these two populations, one is outside the halo, one is inside the halo, quench. And we found that you really need both halo mass and assembly bias to describe how they quench over time. And you can learn more about our work, which is the first two columns. And then the third piece is that we also investigate how disruption effects of the galactic disk cause on these subhalo populations, and they do create a mass-dependent effect.
Thank you.
Hi, my name is Mahalet. I'm a third year grad student in RISA's group, and I have a poster on comparing different galaxy formation models using the bias expansion. So the motivation behind this project is that we have a lot of really interesting surveys coming up, like LSST, and we want to be able to take advantage of all the survey data and extract as much information as we can. So the approach that we're taking with this project is to try and better understand the connection between galaxies and dark matter. So we're using galaxy bias and a specific bias expansion model, and measuring the parameters in that model for different populations of galaxies, quenched star forming, and different galaxy formation models like universe machine and TNG. So come by my poster if you want to see what we measure for the different galaxies.
Great, thank you.
Hi, everyone. I'm Kirit Kokari. I am a new staff scientist here at SLAC. As you're going to hear about in the next session, a lot of us are very excited about line intensity mapping as a new way to observe the extremely high redshift universe. I'm particularly excited about line intensity mapping at millimeter wavelengths, where we observe far infrared lines, which are very bright in early galaxies, and we can reuse existing CMB platforms. But to do this measurement, we need new detectors, millimeter wave spectrometers. And so for the last few years, I've been developing on-chip millimeter wave spectrometers, and I'm now leading a new experiment called SPT-SLIM, the South Pole Telescope Summertime Line Intensity Mapper, which is going to demonstrate this new technology on sky. I'm really excited about the potential this has for next generation large-scale structure measurements. I'm also looking for students and postdocs, so please talk to me if you're interested, and come check out the poster. Thank you.
Thanks.